So in this video, we'll be looking at angles inside a triangle, and there will be a link to a worksheet where you can practice everything you've learned from watching this video. Now, the key principle that you need to make a note of either in your exercise book or your revision notes is that all interior angles inside a triangle add up to 180. Now, it doesn't really matter what type of triangle that is, whether it's a right angle, isosceles, equilateral, or a scalene triangle. The three angles inside a triangle will add up to 180 degrees. Now, if you were to draw a triangle, cut out the angles, and then attach the angles like it was like a bit of a jigsaw, then you would find that those three angles would would lie on a perfect line. And that's one of the key principles of this particular rule. And we get the yellow, which is the only one that's missing. And like I said, this is a key principle that we're going to be recalling when we go through several examples to answer questions involving angles and triangles. Now, there are a few other important angle facts that you need to be aware of. If you weren't aware of, again, I'll make a note of this. Is that angles on a straight line add up to 180. So here, if you've got a line and it's broken up into several types of angles, so in this case we've got three angles, then the sum of those three angles is going to add up to 180. And the second point is that angles around a point, so regardless of what size those angles are, whether they're reflex, acute, or obtuse, they're going to add up to 360 degrees. So again, it's definitely worth adding these points, and generally you find that when you've got questions involving angles and triangles, that they're going to somehow incorporate these two possible rules. So let's have a look at some actual questions. So here in this particular example question, it says work out the angle of x. Now, the one thing you don't want to do when you get this type of question in your exam is to reach for your protractor and start measuring the angles. Now, I would say there is going to be a very, very high chance that none of these triangles are ever going to be drawn to scale. So the purpose of you working out the angle of x is not to measure the angle with a protractor. So in this, what we've got to do is we've got to remember the rule that the three angles added together add up to 180. So in terms of working this out, so here we've got that if I add x plus one of the angles and the other angles all add up to 180. So if I add up these two numbers, I'm going to get 110. So I need to find out what number do I need to add to 110 gives me 180. Well, the opposite of adding 110 is to take away 110. So I've got x equals 70 degrees. Now, there are several ways in which you can do this. I've kind of combined this particular method with solving equations, but again, it's entirely up to you. Another rule is basically to find the missing angle inside a triangle, add together the two known angles and subtract from 180. Now, that's the general rule, but like I said, if you can try and make sense of this particular method, then that is probably a much better way of dealing with it. So let's move on to another type of question. So here we've got is to work out the angle of x. Now here we know one of the angles, but this angle here isn't labeled. However, it is labeled with a little box. Now that little box basically implies that it's a right angle triangle and that it's 90 degrees. So if I add 90 plus 35, which is going to give me 125. And so then I know that the total sum of these two angles, so this one here and this one here, adds up to 125. So the only thing I've got to do is take away that from 180 and I get the answer of 55 degrees. And there is my final answer. Now, in an exam, you'd probably write it as x equals 55 degrees. But again, I'm sure that as long as you wrote down 55 degrees and highlighted it in some form or another, then that would be absolutely fine. So let's have a look at another question. Now, sometimes you might get a question where you've got some missing angles, angles that aren't implied. Now, again, to work out the angle inside a triangle, you need to know what the other two angles are. Now, in this particular triangle, if I just highlight this here, so here is my triangle, which I'm just highlighting in a yellowy gold. So I know what this angle here is, but I don't know what this angle here is, and that's what I need to find. So in order to find that, I notice that the 120 and this angle, that the gold angle that I've highlighted, all lie on a straight line. So if I just call this angle, let's say A, I know that A plus 120 adds up to 180 because angles on a line, straight line, add up to 180. So if I just write angles on a straight line add up to 180 degrees. Now let's just get rid of that random line. There we go. So to work out A first, so you always need to work out what sometimes the missing angle is. So A in this case is going to add up to 60 degrees. So I know that this angle here, I can cross out A and label that as 60 degrees. So now I know what the two angles in the triangle are. So I've got 50 plus 60 plus A adds up to 180. So I add these two angles up and that becomes 110. So then ask myself, what do I need to add to 110 to get 80? Well, the opposite of adding 110 is to take away 110. So A equals 70 degrees. And there is my final answer. So then moving on to question 4. So again here, I'm looking at my triangle, which again I'm going to highlight in red. So here is my triangle. Now, unfortunately, to work out x, which is inside the triangle, I don't know what the other two angles are. So what I'm going to have to do is use these rules. So if I just call this A and this B, that in order to work out x, I need to work out what angle A and B are going to be first. So looking at A, so I know that A plus 105 equals 180. Why? Because they lie on a straight line. So then here, the opposite of adding 105 is to take away 105. So A equals 75 degrees. So I can cross out A and I can label that as 75 degrees. Now looking at B, I know that B plus 140 degrees, again, has also got to add up to 180 because they're angles on a straight line. So again, opposite of adding 140 is to take away 140. So B equals 40. So again, I can cross out B and label that as 40 degrees. So now to work out x, I've now got what the two missing angles are. So x plus 75 plus 40 adds up to 180. So here I've got x plus 125. And I don't know why I put that little mark there. So let's get rid of it. Equals 180. So then opposite of adding 125 is to take away 125. So x is going to equal 25 degrees. And there is my final answer. So if you do see any missing angles, again, this question in an exam would be worth, let's say, 3 marks. You get 1 mark for working out what 75 is, 1 mark for working out 40 degrees, and then 1 mark for finding out what x is. And again, what you could probably get away with, and a common question I always get asked as a teacher is, do I need to show this working out, particularly in an exam? Well, yeah. Now, typically, what you'd find now is that with more modern day exams, they are now allowing you to show your working out on the diagram. So you wouldn't have to work it out separately. So you can, as long as you're labeling, as long as you can see 75 and 40 somewhere in your working out and the final answer of 25 degrees, then it's looking good for you to get full marks. So let's have a look at the next question. So again, I've got a missing angle here. Now here, the angle I've got to find is not in the triangle. So this, in order to work out x, I need to know what this angle here is. And in order to work out what the red angle is, I need to work out what this angle here is, because obviously angles in a triangle add up to 180. So I know that these all add up to 180. I know that these two are going to add up to 180 because they're on a straight line. And then by working out what those two, the green angle is, I can then work out what the red angle is, and then work out what x is. So it's kind of like a threefold question. So the first thing we need to do is find out what this green angle is. So working out what this angle here is, it's going to be 123 plus, now if I just call this A, equals 180. Now again, the opposite of adding 123 is to take away 123. So A equals 57 degrees. So this angle here is 57. Now from that, I can then work out what angle this is, which I'm just going to call B. So B equals 180 minus 42 minus 57. So again, if I was to work that out, I'll get the answer of 180 minus 42 minus 57 gives me an answer of 81 degrees. So this angle here is 81. Now again, because I know that the rule of angles on a straight line add up to 180, I can then work out that x plus 81 equals 180. Take away 81, so I've got x equals 99 degrees. And there you go. Now the key thing with regards to looking at questions involving angles is that, does this angle look like 99 degrees? Probably not, because 99 degrees is quite close to a right angle. So you'd probably say that if that's 90, then 99 is going to probably look something like, looks like that. And that angle here looks completely different to angle X. Now, as I mentioned, that none of these angles in an angle with triangles are going to ever be drawn to scale. So the one thing that I would say is make that if the angle in the diagram looks obtuse, which in this angle it is, then your answer should also be obtuse. But never really reflect on thinking, well, hang on a second, I've got an angle of 99, which is quite close to a right angle, and no way does angle X look like a right angle. Do you then start doubting your methodology? So again, the key principle to take away from these is, are diagrams ever drawn to scale? No. But an obtuse angle will always give you an obtuse answer. An acute angle will always give you an acute angle. Questions will never be drawn in a way that's going to be like contradictory or to give you a different answer. So again, let's have a look at question 6. So here we've got no diagram. So the question says that, is it possible to draw a triangle with angles of 150, 20 and 20? Well, the key principle about angles inside a triangle, and that's the key two words in this particular question, is that angles inside a triangle must add up to 180. So what we need to do is check that these three numbers that we can see add up to 180. So 150 plus 20 plus 20 actually adds up to 190 degrees. So the answer to this particular question is no, it is not possible to draw this triangle, as the angles do not add up to 180 degrees. Now, this is really, I wouldn't say a high level question, but the way I've structured this particular answer is high level. And the reason why it's high level is because here I've stated my proof, here I've stated my evidence, and here I've stated my conclusion. So in other words, what I've stated here is a perfect answer to a proof question. So one, you want to state a fact, which is angles in a straight line, angles in a triangle add up to 180. You then want to show your evidence, and that's in the form of a calculation. And then you want to kind of show your general answer of what that actually means. And that is a perfect answer to any form of proof question that you may get. So again, let's have a look at question 7, or example 7, I should say. So here it says that the drawing shows an isosceles triangle. So though the question is never drawn to scale in terms of measurements, the indications of this show it's an isosceles triangle. Why? Because that's what these two lines represent. And if you're not too sure, there is a video on shape vocabulary that I strongly recommend that you watch if that makes absolutely no sense. Now, the key principle of an isosceles triangle, and you usually find that any key information in the exam will be written in bold lettering. So it's always worth making notes. So what do we know about isosceles triangles? Well, we know that isosceles triangles, well, two sides are the same, and also two angles are the same. So the two sides are just divided with the lines, but we're not talking about lines. What we're talking about are angles. Now this angle here is going to be the same as this here. So that's also going to be 65 because it's an isosceles triangle. So now that I know what the two angles are, I know that A plus 65 add up to 180. So I've got A equals A plus 135, or 130 I should say, add up to 180. Opposite of adding 130 is to take away 130. So A equals 50 degrees. And there is my final answer. Moving on to the next question. So here it says that this shape has been made from two identical isosceles triangles. So these two triangles are identical. And the question is asking me to work out the angle of X. Now, in order for me to work out the angle of X, I need to know what this angle here is. And I also need to know what this angle here is. Now, it says here that the angles are identical. So that means that if this angle here is 25, that this angle here is going to be 25. And because it's an isosceles triangle, this angle here is going to be 25, and this angle here is also going to be 25. So to work out the size of this red angle, it's going to be 180 minus 25 minus 25, which equals 130 degrees. So this angle here is 130. And if I do the exact same for the blue angle, 180 minus 25 minus 25 is also going to give me 130. I can then use the rule that angles inside or around a point add up to 360. So therefore, X plus 130 plus 130 add up to 360. Again, if I simplify this, I get X plus, I don't want to keep writing equals. So here we've got X plus 260 equals 360. Again, don't know what is going on with my labeling there. Equals. So again, opposite, adding 260 is to take away 260. So I've got X equals 100 degrees, and there is my final answer. And again, always take a notice. I can see that angle X is an obtuse angle. And is the answer an obtuse angle? Yes, it is. So there's a good chance that I have got this question correct. So next thing we move on to is more your extension questions. So this involves more your high level questions and will generally involve you finding angles, multiple angles, but also angles that you're not explicitly need to find. So this particular question kind of combines a lot of factors together and is very reliant on you getting the correct answer for the early parts of the question. Now, when you have got a question that involves multiple letters, then generally speaking, a good technique is to answer it in alphabetical order. So here I've got the angles of X, Y, and Z, and that is the exact order that I'm going to work out what these angles are. Now, the first thing I notice about angle X is that I can't use the angles of a triangle that add up to 180 because I don't know what, that's obviously a triangle that involves X, Z, and 90. However, one thing I do know I can spot is that it lies on a straight line. So angle X and 110, so X plus 110 must add up to 180. And why? Because they're on a straight line. So therefore, the opposite of adding 180 is take away 100. Sorry, opposite of adding 110 is take away 110. So I know that X equals 70 degrees. So what I can do is I can label that as 70. Now, then working with the next letter, I can see that Y is part of this triangle here, which I should use a different color, so let's use red, which is part of this red triangle. And with angle Y, do I know the other two angles? Yes. So I know that Y plus 40 plus 110 equals 180. So again, if I add these two things up, I get 150. So what plus 150 gives you 180? Well, Y equals 30 degrees. So Y is going to equal 30. And then working out with Z, now again, I didn't really need to know Y to work out Z, but if I just highlight this particular triangle involving Z, let's just draw that triangle out again. I know that this angle here is 90 degrees. I know that this angle here is 70. and this is the angle Z that I need to find. So I know that Z plus 70 plus 90 equals 180. Combine these two things together and I get 160. So what plus 160 gives you 180? Well, that's going to give you an answer of 20. And there you've got your answers to the 3 parts that you are looking for. And then finally, moving on to the last example question that we're going to do in this particular video. Here we've got, again, another extension question. And the key bits of information are in the initial parts of the question. So it says, look at the triangle ABC. It says ABD is an isosceles triangle. Now the triangle of ABD is the points of going from those 3 letters. So A to B to D, you can see form a triangle. And that triangle that I'm highlighting in red is what we call a triangle ABD. And it says that this triangle here is an isosceles triangle. So what we know is that X plus Y equals the same number. So working with this particular angle, we can know that 52 plus X equals 180, because if these two angles are going to say, then I might as well call that one X as well. So here I've got 2X plus 52 equals 180. So again, opposite of adding 52 is to take away 52. So I've got 2X equals 128. What times 2 gives you 128? So X equals 64 degrees. So these two angles here are going to be 64, and that's going to be 64. Now looking at this angle here, I know that angle Y and this angle, which I'm just going to call A, lie on a straight line. So A plus 64 equals 180. So A is going to equal 116, it's going to be degrees. So this angle here is 116. Now, working with this triangle here, which I'm just highlighting in gold, so in other words, triangle ACD, I know that this triangle here, I know what the 2 other angles are. So I've got Z plus 116 plus 44 add up to 180. So Z plus, and if I add these 2 numbers up, I get 160, add up to 180. Opposite adding 180 and 60 is to take away 160. So Z equals 20 degrees. And there is my final answer. So the key principle in this particular question, or this particular topic, I should say, is remembering that angles inside a triangle add up to 180. Now, with easy questions, in order for you to work out the missing angle in a triangle, you need to know what the other 2 angles are. And that should be your main objective, is to find out what those 2 angles are. Now, in easy questions, you'll be given what those 2 angles are. But as you can see, in more complicated questions or high level questions, it might be the case where you need to find out what one of those angles are, or if not both of those 2 angles are, by using other properties of angles on straight lines or around a point R. So it's definitely worth making a note of those. And again, just to re-emphasize what those actual properties are, if this decides to scroll up in the speed that I'm talking. So again, the main principle is that angles inside a triangle add up to 180. Angles on a straight line add up to 180, and angles around a point add up to 360. So it's just a case of applying those 3 sort of main properties of angles to answer these types of questions.